Hello everyone, this is Javamonk, and welcome to a video where I show you how to build a 3D printer in Minecraft. This is an update to my world's fastest 3D printer design. So please enjoy my very amateur attempt to use the replay mod as it 3D prints a statue of a wither. So of course, I have made both a showcase and a block-by-block tutorial for this 3D printer design, although that was back in update 1.14. This design has largely stayed the same since 1.2 carrying over into 1.16. For example, this part down here, the printing bed where your actual 3D print will end up, it is still expandable infinitely, going this way along what I'm calling multiple rows. This part right here is what I'm calling a row. It can also extend that way, and it can extend upwards fairly seamlessly too. Now, what broke in updates 1.15 and 16 was this one piston right here that kind of made everything work, and that one piston behaving weirdly has caused this entire structure to be needed, and also an extra couple blocks over here for some very bizarre reason. I'm now going to demonstrate what that bizarre reason is that warranted a fairly sizable redesign. So the redesign was caused by this mechanism right here. You might be familiar with it if you've ever dabbled with what I kind of jokingly call dark magic redstone. And it deals with this. This is a zero tick piston. And it's called that because it literally pushes and pulls blocks instantaneously. I really do mean instant. See? I have the tick rate set to 1. If that piston were not there, this would take a full tick to extend like this. It still takes a full tick for this thing to extend, unless there's a piston here, in which case it's instant. So the problem that showed up was in dealing with these zero tick pistons, because gravity blocks dropping onto the piston, totally fine. No problems whatsoever. The problem comes in when you try to pile on five gravel all at once. So this thing can only really handle 2 gravel all at once in a pile. You put 5 in a pile and drop them all into this piston, and you're going to get a lot of gravel being broken like this. And that's not good when you have hyper-precise 3D printing instructions involving gravity blocks. So I needed to basically redesign the entire row placing setup. Now, as for why an extra 2 blocks were added, and something I made a big deal about, also has to deal with this magic zero ticking machine. Watch this. You would think that when I place another gravel, it's just gonna fall right here. This gravel here is just gonna fall right there, right? Well, if you extend too quickly, which the 3D printer does extend these pistons that quickly, you can end up with something like this. Why? I don't know. I really honestly don't know. This kind of stuff with zero ticks is way out of my line of expertise, but I dealt with it to make this 3D printer work. But once you make those changes, this 3D printer can essentially be extended to whatever size you want, including 54 by 54. Generally, multiples of 27 work best as the number of blocks for your row because of the way the shulker boxes are handled. So 54 by 54 works totally fine. You can also do the 81 by 81 island that I 3D printed back in the early days of 3D printing when I did this in survival in my survival series episode 42. This thing can be 3D printed with this design. And who could forget this absolute monstrosity of a machine? This 270 by 249 print by 62 layers. Yeah, this is the almighty Ender Dragon statue 3D print. Yeah, it is intensely laggy. But the cool part is that I am using the carpet mod, which means I have the ability to do /tick rate 100 or 200 or something like that. And what that does, I would absolutely recommend the carpet mod if you are actually going to build this 3D printer for any reason or use it in any way whatsoever, because it will massively speed up the printer by essentially making the game run faster. As far as I know, this is the fastest possible 3D printer that even can be built. So, yeah, this is a world record. I set this world record about a year ago with the older design, and now with this newer design and some less stupid of a design for the instruction module, I'm going for the world record again, this time no misprints. And of course, I called the size of this printer go big or go home. And I'm not going home this time. I'm going big. Coming back to this 3D printer, this video is a tutorial. It's going to be split into 2 parts. The first part is going to be a block-by-block tutorial, which, if you are downloading from the world downloads that are provided in the description, you can skip this block-by-block tutorial. The link to do that is on screen right there. Go ahead and skip it. You will be skipped to a part of the tutorial where I show you how to program the 3D printer with your own instructions, also using data packs that I personally designed to help you program this printer. If, however, you plan to customize the size of your print, I would recommend sticking around for at least part of the block-by-block tutorial because it is relevant to seeing how to expand the printer in whatever way you choose. Although, even there, I'm still going to have a link where you can skip the part that does not extend anywhere. And again, it'll let you skip to the part where we make the instructions. And with that, let's commence with the block-by-block building instructions. This 3D printer is infinitely expandable. What that means is that there will be parts of this block-by-block tutorial that you can just extend for however long you want, but there are there are some parts of the machinery that do not extend. So there will be a few different parts to the 3D printer that we'll be building, one part at a time. Part 1 is going to be the printing bed. So the printing bed is the center of the entire build. And so you need to determine how large your build is, as well as where you are going to position it. This tutorial, I'm going to show how to build the 27 by 27 version. I'm also going to show you what to do when there is an even number of blocks in a row or a layer, or an even number of rows in a layer. The second part of the tutorial, part 2 of the machine, is going to be also expandable. It's going to relate to these flying machines as well as this setup right here. I call this the row placing mechanism because, well, it takes a row and it positions it into the printing bed. And then everything else in the machinery is set in stone. It stays constant. It does not change depending on the size of your build. And then the instructions part, that does expand with the size of your build. So there's multiple components. Let's go and start with the printing bed. To make a 27 wide, 27 long, and 8 block tall printing bed, you will need these materials. These can be any blocks. These can also be any blocks. I just prefer glass because it makes things easier to see. This can be any item you want. And these are droppers. This ice represents frosted ice. You're gonna probably want actual ice so that you can break it and turn it into frosted ice. And then I'll just get all the materials done right away. The row placers for a 27 by 27, well, I guess a 27 block wide row are these materials. You will also need materials for a downwards redstone line. These slime blocks do have to be slime blocks, though. And these can be any trapdoors. These can be any blocks. These can be any blocks, and so can these. But these have to be immovable blocks. In the not expandable part, you have all of this. These honey blocks can be replaced with slime blocks, if that's your thing. And these can be any blocks, as can these. But these do have to be walls. And these can be any slabs. And you need one immovable block. And this is what you need for the program interpreter, or the thing that's going to turn your items into blocks. This is also a set amount. This is a dispenser. These are droppers. You will need some gravel on top of whatever concrete powder that you put into the machine. This water and lava is recommended. This is also recommended, but not required. And these can be note blocks or rails. Also, this lever is optional. So is this button and this lamp. So the first thing you're going to want to build out is your actual platform. This is a 27 by 27 platform in my case, but you can have this platform as large as you want, literally, as long as it's within your render distance. Seriously, it can be any size you want. So next, what you want to do is put a wall around your printing bed. If you are making a one-layer design, then if your print is only going to be one layer, then you're essentially going to be using the 3D printer like it's a 2D printer. And in that case, all you need is this wall. So again, if this is a one-layer design, like your print is going to be only one layer, all you have to do is put in water in these diagonals and then you're good to go with the printing bed. You can just move on to the next step. However, if you have multiple layers, like you're using this like an actual 3D printer, then this process is going to be repeated for every 2 layers. So essentially, take the number of layers that you have in your build, divide it by 2, and you're going to be repeating this over and over for that number of times. So first off, you're going to want a second layer of wall like this. What you're going to want to do is pick a corner. I'm going to choose this corner right here. This is going to be kind of the central corner where everything happens. So if your build is rectangular, meaning that your printing bed looks something like this, you're going to want this corner to go along one of the long edges. And in fact, all of your row placers are going to be going along the long edge of the rectangle. Or at least that's what you're going to want to do if you don't want the print to take forever. So this, however, is a square build, so it doesn't really matter. Once you chose your corner, go out 1 block from that corner, come out 2 blocks like this, and then place a line of blocks 1 block apart from this glass wall here, all the way to the end, just like this. And then put redstone dust on top of this entire row. You're also going to want to do this for the other side where you have your corner marked out. So in this case, that'll be this side. And go ahead and join your 2 lines together. And put redstone on the entire thing. Next, you need to put in your pistons. So once again, pick a corner. I'm going to pick this corner right here to start off. So on one side, break the first block of your printing bed of the wall here and put a piston just like this, facing towards the printing bed. And then skip a block and put another piston. Skip a block, put another piston, and just do this for every other block. Just like this. Now, here, since the number of rows I have is an odd number, your last piston is going to be on the final row here. However, if your printing bed looks like this, as in your piston is 1 block away from the final row, then what you're going to want to do is this. I'm going to simulate what you got to do. So make your redstone line go wrap around like this, and then you need to put a piston. Then you're going to need to put a piston here. You can see it kind of, you have 2 diagonals between these 2 pistons, and then bring the redstone over so that way it can power this piston. On the other side where you have your redstone line, you need a 2 block spacing, and then break this block and place a piston. So you should have a setup that looks like this. And then once again, continue the pattern of breaking the block and placing a piston every other block, just like this. And once again, if the number of blocks in a row is an even number, then your printing bed is going to look like this, where your piston is where the last piston in your row is 1 block away from the edge here. And in that case, you will need to take this redstone line and once again, wrap it around into it at an angle like this, and put a piston right here, just like this, which is 2 diagonals away from your last piston in the row. While we're here, it's a good idea to be able to power these pistons. So in this corner block where the 2 redstone lines meet, place like a redstone torch or something. This is going to be temporary. And wherever your redstone signal runs out, just place a repeater immediately afterwards. This repeater should go in between two pistons, but if it doesn't, just go ahead and put your repeater one block back. The goal is for every single one of these pistons in your row to be extended. And do the same thing for your other redstone line, just like this. You are now ready to put in the frosted ice for this kind of set of 2 layers. So hopefully you have built this in a suitable location, as in you either have a covering, it is perpetually night, or you built this in the end. In general, just a place where frosted ice won't immediately melt. So hopefully you've done that. What you're going to want to do is take your water buckets or your ice blocks, if you're in survival, and place these blocks immediately in front of these pistons, and then walk near it to freeze it, just like this. So basically just, you got to do this. It's a bit of a slow and tedious process, but there you go. We now have frosted ice. And there you go. This is what you need to repeat over and over every 2 layers until you reach the number of layers in your build. So since I have 8 layers in my build, I'm going to repeat this process 4 times. And this is what your printing bed should look like. If you have more than 8 layers, just repeat over and over. But ultimately, even if you have an odd number of layers, like if your build only goes up to here, you're still going to want to put this layer of frosted ice here, because that way the concrete at the very top layer still gets solidified. So now we just need to hook up the redstone to make all this work. To build this system, you just need to place 1 block here and place an observer block facing towards the redstone line. At the very end, we're going to put a block here in front of the observer so that it powers the entire redstone line, but we're not going to do that just yet. So every single one of these needs an observer, just like this. Again, do not place the block in front of the observer yet, unless you want your frosted ice to melt. Now, in front of this observer, place a block and a comparator for each of these, just like this. This is why I said not to put the block in front of the observer yet. Next up, we need to make a dropper line. So place an upwards dropper lined up with this block right beneath this first comparator, and then make a dropper line that goes all the way up to the last comparator in your line here. Go ahead and put a chest on top of that, and at the very end, right before we turn on the machine, we're going to put a random item into this bottom dropper. But we're not going to do that just yet. Instead, I'm going to stash it here for now. So to make this dropper line work, we need to go out 3 blocks, just like this. And we need to make a downwards observer line, just like this. Including this one needs to be a downwards observer. Now, coming off of this downwards observer line, you need an observer facing this way towards the dropper line. And then put a block between the observers and the droppers, just like this. We can now put a block in front of these observers. The printing bed is now complete. Again, to reiterate, at the very last step before we turn on the machine, we're going to put this random item into this bottom dropper. But we're not going to do that just yet. Next, what we need to do is build a downwards redstone line that carries a 1-tick pulse. So there's a few ways to do this. My favorite way, personally, is to use doors and trapdoors. So to do this, place a door on top of the observer, place a block on top of the door, and then put a downwards observer facing into the block, just like this. and then just repeat this over and over until you make this line as tall as you want. Now, be careful about making this too tall because the actual machinery of the 3D printer is quite bulky, and if you make this part too tall, your stack of instructions might bump into the sky build limit. So I'm going to cut it off at this level, but ultimately it really does not matter how tall you make this line right here. Next, we will build the row placing flying machines. This part is expandable, but I'll show you which parts are expandable. So I'll be using gold blocks to measure, and this way you can count along the hard edges of the gold. And I'll be using iron blocks for the build. So from this topmost downwards observer, go out 8 blocks, just like this. And then come back a block like this, and go down a block like this, and place a sticky piston facing away from the printing bed. If you built this right, this sticky piston should line up with the first block in your row in the printing bed. On the face of this sticky piston, place a slime block, and then place a sticky piston facing the other way, just like this. Place a slime block there, as well as here and here. Behind the sticky piston, place an immovable block, and this will stop the flying machine. Place a normal block here, and place an observer right here, facing into this piston. And then place 2 blocks on top of these 2 slime blocks, just like this. Now, put a block of spacing in between. I should use gold blocks for this. A block of spacing in between, and place an observer like this. So there should be 1 block of spacing, and just leave this observer hanging. And now on top of this slime block here, you need to place a downwards observer, just like this. If you built this right, breaking this block should make the flying machine go out 1 block, push this observer out 1 block, and then return. So if you want, you can go ahead and reset that observer and make sure this works. Go ahead and place a sand block on top of either this block or this one, and then update the observer. Those 2 sand blocks should fall directly into the printing bed and should take up these 2 spots right here. Next, come up 2 blocks and over 1 like this from this crying obsidian, and place another immovable block. This is where we're going to build another one of these flying machines. So once again, place a sticky piston here, place a slime block, place a sticky piston facing this way, and place another slime block. And then place 2 slime blocks like this, put a normal block here, and an observer block here, facing into this sticky piston. And then put 1 block of spacing and position another observer just like this. And then put in a downwards observer right there. So once again, this flying machine should also go out 1 block, push this observer out 1 block, and then return. And then put 2 blocks on top of those slime blocks. This process is repeated over and over. So your next flying machine needs to go over 2 blocks and down 1 right here. There should be 3 blocks of space between these obsidian. And it's exactly the same. It's exactly the same flying machine, just placed down below like this. Literally the same, nothing changes. So those 2 flying machines are just placed over and over until you reach the end of your row. Note that if you're using the /clone command, you could end up with this situation happening where one of the flying machines just decides to do this for some reason. So in that case, it's really helpful to have a command block like this, a repeating command block, which essentially removes itself as soon as you place it, like this. This is really helpful to just update these observers. And they essentially act like Flint and Steel used to before they removed the ability to use Flint and Steel to update observers. And if you have an odd number of blocks in your row, that is perfectly fine. Yes, this is an even number of flying machines, but that just means that one of these blocks will just go unused. One of the blocks used to carry the sand and concrete. But you still need to place the entire flying machine. Next up, come up a few blocks and place a downwards piston with one block of space between the downwards piston and this observer right here. And just do that for every single one of these observers. Just like this. Once you've done that, you'll need to place a kind of zigzag pattern right behind the pistons, just like this. A bit like this. And put redstone on top of the entire zigzag. Let's make sure that this actually that all of these pistons can be powered. So at the top of this first zigzag, place a block and something to power it with. So this should send off most of the flying machines. So go over to the last redstone that isn't powered, which looks to be this one here. So break this redstone dust, replace it with the repeater, and then you might have to wait for this flying machine to come back. And then put a block on top, just like this. So there you go. Now all of the pistons are powered, and the joys of doing things in the order that I tell you to. Now, this part is really easy to do. On top of these observers that are on the top of the kind of zigzag here, put a block of space and put a piston facing this way. And now you can depower these pistons. And watch your flying machines go. This half of the row placing flying machines are now complete. So now we need to make the machines that reset these observers after every layer. So the way we do that is we go to the end of this redstone line, to the end of the printing bed right here. And on top of this, we're going to place a tower of scaffolding. This tower of scaffolding needs to go up to the y coordinate of this observer right here. You can see the y coordinate labeled right here with an arrow. We need to go to that y coordinate -1. So in this case, we need to go to y19. And now to the side of this scaffolding tower, place a block. So coming off of this block, this little segment is actually not, this is actually in every single machine. It is not part of the expandable part. So come back a block towards the printing bed and place a repeater on top of that, set it to 4 ticks, and place a redstone dust there. And now make a staircase that goes up 4 blocks like this. Put redstone dust on all that. Place a block here with a repeater set to 4 ticks. And then come up a block and over 2 blocks. Put a dust here and 2 repeaters, both set to 4 ticks. Just like this. And now we're back to the expandable part. So coming off of this next block here, place a trapdoor. Underneath this trapdoor, place an observer and a slime block underneath that. Then place a sticky piston here, facing towards the printing bed, and put an immovable block behind it, just like that. Now put a slime block here on the face of this piston, and put another sticky piston facing in this direction here, just like this. And now put another slime block here, put an observer, a downwards observer right here, and an upwards observer right next to it. Next, you need to build a bit of an L shape like this, and then put 2 blocks, one here and one here. There we go. This is the flying machine that's going to push the observers back to where they started. And there we go. This is something we just need to build over and over again. So make a 3-block spacing, put redstone on top of this redstone on top of the blocks here. And then on the 4th block, put another trapdoor. And here we're going to build another one of these flying machines. So there should be 3 blocks of space between these trapdoors. So once again, I'm going to go over how to build these flying machines. Put a downwards observer on the trapdoor. Get a slime block. Put it on the observer like this. Get a sticky piston facing this way. Put some obsidian behind it, or a movable block. Put a slime block on the face of the sticky piston. Then swoop around and put a sticky piston facing this way. And now put a slime block coming off this way. Put a downwards observer here. Downwards observer right there. And an upwards observer right here. And then make an L shape and put a block here and here. There you go. Just repeat this over and over. The number of flying machines you're going to have over here is going to be the same as the number of flying machines over here divided by 2 rounded up. Again, note that if you're using the /clone command, your flying machines are probably going to look something like this. So to resolve that, you can just quickly flip the trapdoors up and down and move the flying machines back to where they're supposed to be. Like that. Next, we need to make sure that every single one of these trapdoors gets powered. So briefly remove this repeater and replace it with something like a redstone torch. It's going to send the flying machines off. That's perfectly fine. And then wherever the redstone stops, it should be, you can just put a repeater, no problem, as long as the repeater doesn't go on the block that also is powering the trapdoor. So every single one of these trapdoors should be powered. And you'll also see if you placed these normal pistons correctly, if the flying machines move these observers to have a spacing of 1 block between the row placing flying machines. And it looks like that is the case. And then just remove the redstone torch and place a repeater set to 4 ticks. If you want to check that you positioned these flying machines correctly, what you can do is grab a redstone block, place it at this flying machine. You're going to need to place this redstone block anyway. And then break this observer, go all the way over here, and put it over here, next to 1 block away from this block of this flying machine. Oh, and since this is the first flying machine, put an observer to the side, sticking out of the slime block just like this. This way we don't have to come back here after this test. So now take 2 gravity blocks like sand, and then update this flying machine. So what should happen is this flying machine goes all the way to the end. It should drop the sand at the last row. Just like that. And then it should send all of the flying machines back and closely follow this flying machine on its return. Just like that. It works. We now no longer need to go to this side of the printing bed at all for any reason. All the redstone is now going to be localized here. So from this observer right here, come up 9 blocks. Just like this, we're now going to place the blocks that are going to kind of keep the rows before they get dropped onto these flying machines. I'm going to mark these out with emerald blocks. So I'll just carry these all the way down. You should have as many of these blocks as you have blocks in the row of your printing bed. Just like this. And this part you got to place in no matter what. At the very end of this row, place an immovable block using cyan obsidian. Behind this emerald block line, we need to place a piston facing towards the line like this. And in fact, we need to place a whole line of pistons just like this. And behind the pistons, we need to put a line of redstone just like this. Now we need to make sure that all of these pistons get powered. So come back a block here, place a redstone on top of that, and then come back another block, and this is where you put your power source. So we're using a redstone torch as a temporary power source. So when the redstone line runs out like this, at the very end of that, break the first kind of dead redstone dust and place a block in its place. Then come back 2 blocks, come up a block like this, and place a redstone dust on top of that. Place a block here and a repeater. Now come up a block to the repeater, place a redstone dust on top of the block, and then put a block right here in between. And keep doing that over and over until all of these pistons are extended. Then you can just break the redstone torch and they should all retract. Next, we need to come out 8 blocks along this emerald block line right here. And now we're going to put in the system that basically kind of with redstone extends the piston push limit. So on the 8th block here, place an observer facing upwards. And then put a block on top of the observer. Now, put a block after the observer and put a slime block. And then get another block and put a sticky piston facing the slime block. Now place an observer on top of the slime block and a normal piston on top of the sticky piston. And then what we need to do is take the blocks and wrap it around so that it comes up to the sticky piston and put redstone on all of that. So what should happen, if you place a block underneath this observer, this slime block should very quickly move backwards and forwards, like this. There you go. You'll now need to repeat this process all the way to the end of the row. So come back 3 blocks from this last sticky piston here, put your upward observer, and then this is where you make another one of these systems. So once again, observer, 1 block of space, a slime block, 1 more block of space, and then a sticky piston. Then put an observer on top of here, on top of the slime block, put a normal piston on top of the sticky piston, and then make a redstone line going all the way like this with redstone on top. Just like that. So basically just repeat this over and over until doing this 3 blocks and then what's going to end up being 5 blocks of space. One of these takes up 5 blocks. If these 5 blocks takes over enough where one of them touches this obsidian here, then you don't need to build that next setup. I hope that makes sense. Okay, we are now completely done with all of the expandable parts of the 3D printer. And now things get a little bit hairy. So coming down 1 diagonal from this redstone block, place another block right here and put some redstone on top of that. You're not going to want to make a redstone line coming towards the end of the printing bed like this with redstone on top, and stop when the redstone power runs out, like this. So power runs out here. So now come back a block right there and put a repeater going this way, set to 4 ticks, and then come up a block from the repeater, put a redstone torch on top, put a block on top, and a redstone dust, and then put a sticky piston right next to the redstone dust. On top of this sticky piston, grab your honey/slime blocks, and you need to go up 6 blocks like this, and then put a redstone block on the side like this, and then go up another 4 blocks and put a redstone block on top. You should have a structure like this. Coming off of this redstone block, just right on the side, come out 2 blocks, and then over 6 blocks, like this. Like this. There you go. 6 blocks. Put redstone on top of that, and then come out another block, place a repeater set to 4 ticks. Now we're going to build a pulse extender. So make a structure like this and grab your comparators. And then place 2 redstone here, place a comparator going this way with a block in front of it. Put a redstone next to a block and another comparator like this. And then from there, go over 5 blocks like this and put repeaters on top of all 5 of these blocks, all of them set to 4 ticks. Just like this. Okay, we're about to build a very strange part of the circuit. So by the way, if you space things out correctly, the end of the repeater line should kind of line up with this emerald block line here. So, coming off this emerald block line, come out 2 more blocks and place a sticky piston like this. Also, so now we need to build a system that's going to look rather strange and could potentially be a little bit unreliable. Nonetheless, we're going to attempt to build this. So you're going to need a lectern or something that gets a comparator output. I'm going to use a lectern and a book to do this. So we might need to adjust the design based on what happens. So coming out 2 blocks right here, place a comparator right there, and put your lectern and book. There you go. And then come out a block, place a redstone and a target block next to the sticky piston like this. And then underneath the target block, put a normal piston. So now we got to test and make sure this actually works. And the way we do that is by placing a block in front of the sticky piston. Okay, it appears this works. So if however, that does not work, then you need to break that normal piston and put it on top of the target block. And the way you tell if it doesn't work is if you get a shaky piston like this. And to fix this, you just need to break the redstone to get it back to normal. So again, what should happen is you get this and not this. One thing I should mention is that this comparator output needs to be of signal strength 1, like this. If it's more than 1, it could potentially break. So next we need to grab an observer. Let's do that. And place it coming off of this sticky piston. And then come down a block like this. And now we're going to build a pulse extender. This is going to be the main pulse extender that kind of decides when the row is complete. And the way we do that is to place a repeater here, set to 4 ticks, and then place a block here, come up a block there, and then build out a little platform that looks like this. So now we need to place a redstone here, 2 redstone there, 2 comparators going this way, and 2 comparators going that way. Now we're going to build one of the most intricate parts of this entire circuit. So coming off this redstone, you need to place a block and a redstone on top of that. Then you need to come down a block like this and place a repeater right here set to 4 ticks. Place a block in front of the repeater and 1 block down like this. And then place a redstone. And now over here, you need to place 5 blocks coming this way. like this, going underneath this observer, with 5 repeaters on it, all of them set to 4 ticks. And then at the end of here, you need to place a sticky piston facing up, a block on top of that, another block, and a repeater. Leave it on 1 tick. It's kind of hard to show because it's, yeah. At the end of this repeater, come up a block, and then go up 2 more diagonally like this. You should be lined up with this lectern. And then come up another block, and over a block, like this. On top of all these blocks, go ahead and put some redstone, like this. And then at the very end here, place a normal piston facing this way. And you'll also need to place a normal piston facing this way underneath it, like this. On top of this comparator, you need to place another block. I'm marking this with an emerald block because this is one of the important row placer blocks. Then come out 2 blocks like this, place a comparator and your comparator setup with the lectern. And now place a slab on the other side with redstone and a block right there. Next up, come back to this redstone here, place a block on top of it. You need to place a slab here and a repeater right here, set to, actually leave it on 1 tick. Place a sticky piston on top of the block with a target block on top of that. And then place a block here, put some redstone there, and place a block there with a repeater on top of it. Repeater set to 4 ticks. Next up, on top of this repeater, place a block, and then come up 3 diagonally like this. 3 blocks. Then come up a block diagonally like this, and make a little L shape. And then put redstone on top of all of this. From there, we now need to place a block here, and place a repeater set to 4 ticks. Now here's where it'd be kind of helpful to place a temporary power source here. So you're going to notice that these pistons are going to fire off. That's intended. So now what you need to do is come up diagonally like this and place a normal piston facing this block here. And then you need a stack of 20 normal pistons like this. Just 4. Just like this. It's going to be very tall. Now, come up a block here, and then place another block, and put 2 redstone. We're going to be powering this entire tower of pistons. So what you'll need to do is place a block every other piston like this, going all the way up the tower, with redstone on top of it. Just like this. So now at the bottom block here, come up a block. You'll need a transparent block like glowstone, glass, or slabs. I'm going to use glass for this. And place redstone on top of that. Then place another glass there, and another redstone. And then just keep making this tower of glass and redstone, going up diagonally like this. Hopefully you can see this okay. Just need to keep going. Even if the redstone signal runs out, just keep building this. Notice that the redstone signal ended here. That's important. But we're going to keep building this tower. Just like this. So the redstone signal ends here. So come down a block from there, place a block here, and a repeater. Then come up a block from the repeater, and just make a little L shape like this, and put redstone on top of that. The entire piston wall should now be extended. And if that's the case, you can remove your power source and replace it with the redstone. This part's a little bit tricky, but next we need to put a redstone block here, like this. Now we need to place a sticky piston right here. Right there, I said. And then we need an observer facing down into this sticky piston, like this. Now you need to grab your walls. So we now need to build 12 walls on top of this observer. And specifically, the wall we need to build is going to be 3 blocks wide, like this. So we need 12 of these. There's 4. Next, place a block on top of the walls, place a block here, and then you need a downward sticky piston facing this way. Now break the block you just put on top of the walls and replace it with a slab, and then put a repeater set to 4 ticks. Now assuming you built this right, this will be 3 blocks away from the piston tower, and this repeater, need to put some repeaters here, this repeater will be lined up with the 3rd piston from the top. Looks like this is the case, so now on the other side of the pistons, place a block and a comparator, and then your little lectern setup thingy, just like this. And now, if your piston tower is currently extended, then you need to come down to the bottom and break the redstone block and put it back on the face of the piston. Going back to this main pulse extender here, place a block here and a repeater, leave it on 1 tick, then come up a block and make a little L shape, put some redstone dust on top of that, and then come up another block and put a redstone torch. So now what we need to do is hook it up to this circuitry right here. The way we're going to do that is come out 3 blocks, place repeaters set to 4 ticks, like this, then place another block with a redstone on top of that. Now we need to space out a block and put a redstone block on top of that, and then a honey block / slime block and a sticky piston facing downwards into the honey block, just like this. Coming off of this sticky piston, place a little L like this, put a repeater here set to 4 ticks and a repeater here set to 4 ticks with redstone in between, and then connect these blocks here and place a redstone there, come up a block here and put a redstone on top of that, and then put a block and put a block here, put a repeater, leave it on 1 tick. Now we just need to bridge these 2 here. So coming off the redstone torch, place a block and a redstone dust with a sticky piston facing up, a block on top of that, put a block on the other side of the sticky piston with the repeater, and then just connect these 2 with blocks and redstone. And I just realized I made a pretty catastrophic mistake. So when we were determining where to put this repeater extension thing, I put the power source on this block, and that was a mistake. I should have put it back here. Yeah, I guess it pays to double check your redstone. So if you might need to move this repeater system back, as well as all of your other repeater systems. But this shouldn't be too catastrophic. Nothing's that breakable on this part of the circuitry. There you go. Sorry about that. And that also reminds me, we need to deal with this observer here. So grab a repeater, place it on top of the observer, and then put a sticky piston here facing up with the block on top of that. Then come out 6 blocks, 3, 4, 5, 6 like this. That's 6. And put redstone on top of all that. And then take this and go all the way over until you're on top of this redstone line. If you space things out right, this redstone should be at power equals 8. You can see that by the arrow. So now, at the very end here, place a repeater set to 4 ticks, and then connect it all up with redstone. So if you want to double check that this actually works, what you can do is send off the send off these flying machines that move the observers back. And you should see that that observer at the end of the flying machines will power this repeater. Just like that. So, and it should only power that repeater once. So there we go. Now coming off this redstone torch, we need to place a block and put a repeater on top of that, leave it on 1 tick. And now place 2 blocks here and make a little platform that looks like this. So place 2 redstone here. You need to place 3 comparators coming into this redstone block and another 3 comparators coming back from it with a redstone like this. And now over here, over at the main pulse extender, come over a block like this and put a repeater, and then come up a block from the repeater and place 3 blocks like this. So right here, we need to make basically the pulse extender for the on-off switch. So come out 6 blocks like this, and 6 more. And at the end, come up a block and put a block next to that. You need to place redstone here, and then place 6 comparators coming out this way, and 6 comparators going all the way back. Right here, you need to place another block and a repeater on top of that, and then you need to grab a redstone block and power that repeater, just like this. So now, and with that, this entire, and what would also be helpful is if you put a sticky piston on the side right here. We have now finished the row placing mechanism. We're now going on to the instruction interpreter. So on top of this tower of pistons, you need to place 9 blocks of spacing, like this, and then place a block on top of all that. From here, come over a block like this and place a sticky piston, and then make a spacing of 2 blocks like this, spacing of 1 block like this, put another block, and put a sticky piston here as well. And next we also need to put 2 blocks here, and then another block and a sticky piston right here. What you'll also need to do is place 2 blocks like this. This is a recent addition. I don't know why this is necessary, but it's the only way that this machine works. So now you can break that block, and this should line up with the sticky piston right here. Next, we need to make more of those kind of zero-ticking weird mechanisms. So place a block here and a block here, put 2 comparators on top of them, and then 2 blocks there, and 2 lecterns with books in them, or jukeboxes, or whatever you use to make comparators activate. So now place a block on the other side like this, put some redstone on that, and blocks next to the sticky pistons. And now here comes the weird part. Start by putting normal pistons underneath the blocks. That would kind of extend into the sticky pistons like this. And now we need to test and make sure this works. So place a block in front of the sticky piston. And if it's a shaky piston, break the redstone, break the piston, and put it on top of the sticky piston instead. Replace the redstone, and it should work again. Same thing over here. Okay, that works. And if that doesn't work, break that piston and put it on top. Oh, it works both ways. Sometimes it works both ways. Sometimes it works one way. It's weird. Even I don't understand how this part works. You know you're in trouble when the person who designed the machine doesn't know how it works. Next, place 2 blocks here. Place a comparator and your lectern setup thingy. And then On the other side of this line of blocks here, place a redstone, a block and a redstone, a block next to the sticky piston, and then a normal piston underneath that. Test it out. It works. And if it doesn't work, then break that piston and put it on top. And it looks like this is also one that works both ways. Next, come up 3 blocks from on top of this sticky piston and place a slime block right here on the side. So this slime block we're going to use to line up the column of blocks that needs to go up the middle here. So come up 2 blocks and over 1 like this. And now place a tower of 16 blocks like this. And now at the top of the tower, you see where this part extends out a couple blocks? You now need to place 2 more blocks so that the end of this line of blocks here lines up with this sticky piston right here. Diagonally across the slime block, you need to place a glazed terracotta. And now come down a block from the glazed terracotta, place a repeater set to 2 ticks, and then come up a block from the repeater and put a sticky piston on the side of the block. Now come up 3 blocks from the slime block and place another slime block like this. And now we're going to kind of repeat the same procedure. Going to put a glazed terracotta here and come down a block, place a repeater set to 2 ticks, and then come up a block and a sticky piston. What you'll also want to do is coming down from the glazed terracotta, come out 2 more blocks. We're going to be placing repeaters on these blocks with special delays for every single one of these kind of modules here. So for the next one of these modules, you actually need to come up 2 blocks and place a slime block. And then put your glazed terracotta, come down a block, up a block, place a repeater set to 2 ticks, and then go across 2 blocks like this. And we're now going to repeat this part with the 2 blocks and a slime block until there are 8 of these slime blocks here on this side. And now it's time to put the special repeaters. So put a repeater here set to 2 ticks, and put a repeater here set to 1 tick, and put a block behind it. Over here, place a repeater set to 2 ticks, and a repeater here set to 2 ticks, and a block behind that. And here as well, put a repeater set to 2 ticks, and a repeater set to 2 ticks, block behind that. And over here, place a repeater set to 2 ticks, and a repeater set to 2 ticks, and a block behind that. Now here you need a repeater set to 1 tick, and repeater here set to 2 ticks, block behind that. And now for these last 2, just put repeaters, leave them on 1 tick, and still put the blocks behind them, just like this. Now on top of this block, we need an observer facing down like this. And then next to that, we need a bunch of observers just facing down. Basically just make a little triangle connecting this top part here all the way to these blocks, just like this. It's a lot of observers, but that's what's needed to make the timings precise. And on this last one, for this last block here, just come down 10 observers, like this, place a trapdoor at the end, and then finish it off with 3 more observers, just like this. Congrats, we have now built half of this slime block system. We now need to build all of this part right here mirrored on this side. So I'm going to kind of speed through this. So you can place a 3-block kind of bridge here if you want. And then I'm going to actually build this in kind of reverse order. That might actually be more helpful if you're in survival. So again, come down 10 observers, 3, 6, 9, 10. Put a trapdoor. You can put it on that face as well. Come down 3 more observers and place a block, just a block. And come down another block, place 2, and grab your repeaters. These need to be on 1 tick. And then you need a glazed terracotta here, another block there, and a repeater set to 2 ticks. Come up a block from the repeater and place a sticky piston with a slime block. And then we need another set of observers. Okay, actually, maybe doing it in reverse order is probably not the best idea. Come up 3 blocks from the slime block, and yeah, it's basically exactly the same procedure. It's just mirrored. So again, we need to go down a block, up a block, like this, with the repeater set to 2 ticks, and 2 blocks like this. And then for all the other modules, we need to go up 2 blocks before the next slime block. And eventually, there need to be 7 of these slime block modules on this side. And as before, you need to now place all your repeaters with specific timings. So if you can either just look directly across and replicate those same timings. So for the top one, you need a repeater with 2 ticks and a repeater with 1, and a block behind it. Here you need 2 repeaters, both with 2 ticks. And same with here, 2 repeaters with 2 ticks. And also here, actually, yeah, repeater, 2 ticks, 2 repeaters, 2 ticks. And then here you need a repeater with 2 ticks and a repeater with 1 tick. And 2 repeaters, both at 1 tick. And a block behind all of them. And then the final step, just place your downwards observers going all the way across to here. And then all your downwards observers connecting that line to the blocks. Just like this. Over here, we need to place a line of 16 blocks, actually 17 blocks, like this. There should be like an elongated T shape. And then on the back of these blocks, we need a line of 17 pistons. And behind these pistons, we need a bunch of observers. There we go. Next, we need to make a platform that looks like this. So come out 3 blocks from the downwards observers, place a sticky piston facing up with a block on top, and then another block behind that, and another block behind that. This basically needs to be repeated all the way down here. So we need to make a platform that looks like this, being repeated over and over. Next up, we need to place an absolute ton of repeaters. So you're going to need about a stack and a half of repeaters. So we're going to go 1 slice at a time because each of these blocks here are going to be where you put your concrete powder. And this part here is where you're going to put your kind of blank color. Although The colors, the actual colors really don't matter. The order of the colors really don't matter. They only matter as long when we put in the sorting system later. So, starting on this side here, you need to place a repeater set to 2 ticks, repeater set to 2, another repeater set to 2, and another repeater set to 2 ticks. And then on the other side of the piston, a repeater set to 3 ticks. And then a redstone behind it. On this slice, you need the same thing, 2, 2, 2, 2, and a 3, just like this, with the redstone behind it. Next, you need just 2 tick repeaters, like this, all the way down, 5 of them. And same with here, also 2 ticks, just like this. And same with the next one, 2 ticks. After that, you'll need a 1 tick repeater here, and then 2 ticks, 2 ticks, 2 ticks, and 2 ticks. After that, you will need a 1 tick, 1 tick, 1 tick, 2 ticks, and 2 ticks. After that, you need the same thing here, 1 tick, 1 tick, 1 tick, 2 ticks, 2 ticks. For this one, you need a 2 tick, 1 tick, 1 tick, 1 tick, and 2 ticks here. The next one, you need a 1 tick, 1 tick, and 1 tick all the way down here, and then 3 ticks on the other side of the piston, like this. The next one just needs 1 tick repeaters all the way down here. After that, you need also 1 tick all the way down. After that, you need also 1 tick all the way down. And now for the final 4, these are going to be exactly the same. First, you need 1 tick, a block behind the repeaters, like this, and then 1 tick, 1 tick, 1 tick. And put redstone behind all that. There we go. This is kind of also one of the most precise parts of this 3D printer build. So from this redstone over here, you need to come down a block here, place a repeater facing this way, and then come up a block and place a redstone torch. And then on top of this torch, place a block here as well as here. Take 2 redstone, place it like that, and a comparator on top of that. You'll also need to place a dropper right here and some kind of ice like this. You're now going to take this and copy this all the way down. So all of this is going to have repeaters. And you're going to have just blocks with torches and droppers. And actually, the exact center block here does not need this ice. So yeah, ice just needs to go up to the middle point here. Just like this. Next, you're going to need to place a little bit of a rim going all the way across this kind of ice path here, and place 2 buckets of water here and here. They should all meet in the middle with nothing spilling. After that, you need to place hoppers facing downwards into all of these droppers, just like this. And you need to place a hopper facing into these comparators. Again, all the way across. On top of these hoppers, place some droppers facing in this direction, like this, and place note blocks on top of them. We need to place one more dropper right here with a note block on top of that, like that. And coming off of this dropper, we need to place a hopper facing into it and a dropper facing down into the hopper, just like this. We need to place one more hopper next to this dropper, and this hopper is actually going to be where we eventually have the shulker boxes placed. But for now, place a slab next to this hopper, place a repeater on top of that, and then on the other side here, place 2 blocks and 2 redstone dust like this, with a block in front of that. So now what we need to do is place a kind of zigzag pattern like this, going all the way down to the end. You can leave out this bottom block here and put repeaters on all of these. Leave them on 1 tick. Same thing here. Need to make another zigzag pattern, just like this. This time do go all the way to the end. And also need to put repeaters going all the way down. Now, this water stream here, if you want to, you can close it off like this. And another good idea is if you are in survival mode, what I would recommend is to kind of make this dropper filter into something. So personally, what I would do, so what I'm going to do since I'm in creative is make a little bit of a glass tube coming off of this dropper here. Again, this is pretty much up to you what you do from here. And just kind of carry this down like this into some lava. Let me just grab some lava. There we go. I'm also going to place a dropper here and make a hopper line coming off of this water stream here. Because this right here is perfect for 1 hopper to go right in the middle. And again, this hopper stream can go wherever you want. I'm just going to make it go into this dropper, which I'm then going to just make it automatically spit into the lava. And this isn't part of the actual machine. It's completely customizable, but I just made the world's simplest fast ticker. That'll just make the dropper spit out its items. Okay, we're now at the stage where it's probably a good idea to put in your items to filter. At this point, this part is basically completely customizable. So I'm going to do it the way that I did in what you're going to find in every single world download. But again, you can mix and match these colors however you want. So right here, I'm going to have the white concrete powder. And because this slice has the white concrete powder, this hopper is going to be sorting out white dye. You need 41 of whatever your dye item is. The reason I'm using white dye is because the programming instruction, the kind of instruction maker machine that I made, or program that I made, it creates the instructions in the forms of dye. So every concrete powder corresponds to that color of dye in the hoppers. Same case with the orange dye. I'm going to put orange dye in this hopper, which means I'm putting orange concrete powder in this stack right here in front of the pistons. And over here, this is also entirely up to you. You can put a color of concrete powder here if you want. I'm going to use this space for the blank, for kind of the blank color, or yeah, which in this case I'm going to use sand. And using the instruction maker machine that I have, you're going to be using gray stained glass panes to mark your blank spot, like this. Now, if you have something in this middle column, you're actually going to need 5 more of it. And you're going to need to place that 5 more here as well as here. We're almost done with the system that interprets the instructions. So coming down from this dropper, you need to place a block and a comparator on top of it, just like this. And then you need to come up a block from the comparator, place a redstone here, and then place 2 blocks here and here. Next, we need to place a sticky piston right here, place a redstone block on the face of the on the face of that sticky piston. Come place redstone on top of this block, put a block on top of this to cut off the signal, and then come over a block and place another sticky piston here, a block on the face of that sticky piston, and then come down a block from there, and actually you need to place a redstone block there, and a redstone on top of the redstone block. So, small confession, this is also a system that I do not understand how it works, but it should work anyway. This entire 3D printer is now ready to be tested. So if you want to test this entire thing and make sure that you built everything correctly, what you're going to want to do is make a shulker box with every single die, including the blank. So one of these shulker boxes, just like this, remember the order that you put the dies in. In this case, it's nice and easy. I put the dies in the order that they're listed here. And then place this shulker box on top of this hopper, like this. So what you should see happening is every single block is used. Just like that. One of every single block is used. And, oh dear. It appears that somehow I have broken this normal piston. No worries. Just gotta, this right here is actually why you need this entire piston tower, because for some reason, 0 ticking pistons have with the tower of blocks will now just break about every 3rd block for no reason whatsoever. I'm not sure what the Mojangsters did to make this happen or why, but it happened. Try this again. So you should see every single block gets used in the order that the dies were put into the shulker box. Just like that. And over here, we see we have one of every single color in the order that they were put in the shulker box. This system works. We can now move on to the actual instruction handler. So here's the thing. From here, you can basically the 3D printer is essentially complete. The only thing that really needs to be done now is handling the shulker boxes. But if you really wanted to, for some reason, you could just take all your bring all the shulker boxes in your inventory and just manually place them on top of the hopper. I'm not sure why you would want to do that, but you could. I guess if you really wanted to use this as some kind of weird 2D printer, you could just put a double chest here and put a switch here. I don't know. In either case, we're now going to build the instruction handler. So to start off, we need to place a normal piston facing the hopper like this, and we need a dispenser facing the hopper like this. Next, you need to place a block here, as well as a block here. Come down a block from here and place a comparator, and then come down a block here and place a repeater facing into the hopper set to 4 ticks. You might want to place a block there as well. From the comparator, come up a block, place a redstone torch on top, and put a block on top of the torch, place a redstone on top of this, and then place a sticky piston next to the redstone. And now from here, we need to place a block here, and a slab here. Place a redstone, place a repeater this way, and then coming off the sticky piston, place a repeater, connect the diagonals like this, and then fill it in with redstone. This redstone dust is going to become important soon, so come up a block and come out a block like this, and place a repeater set to 4 ticks. And now, but it's not going to be important just yet, because we've got to come down to here, come out another block, place 2 blocks like this, and a glazed terracotta, just like this. Place another block, a repeater right there, and another block with a redstone, and then come down a block like this, and put another redstone. All right, grab your honey blocks, redstone blocks, and sticky pistons. We're now going to be connecting this mechanism to that mechanism down there. So first, we're going to install kind of the on-off switch. So place a sticky piston coming down, and then place 11 honey/slime blocks off the face of this. Like that. Place a redstone block at the end. And now put 1 block of spacing, come down a block, and place a redstone dust on top of that. And then do it again. Sticky piston facing down, 11 blocks, and a redstone block. Once again, 1 more block of spacing, like this, with the redstone dust. And then we need another sticky piston facing down. And this time we're going to go down 8 honey blocks. And put a redstone block there. Yeah. And then come down a block diagonally like this. Come down another one. And place a redstone dust just like this, with a sticky piston facing this way. On the face of this sticky piston comes horizontally 8 blocks. Like this. Put a redstone block at the end. And now put 1 block of spacing. And we need a sticky piston here. And come out 4 more blocks like this. Put a redstone block at the end. And now we need 1 more block of spacing. We need a sticky piston facing down. And now we need to connect this sticky piston to that redstone block there, but not entirely. So put 1 block of spacing between the sticky piston and the honey block. Come over a block like this. Come down until there's 5 blocks. And then connect it to the redstone block. Just like this. Now come over to this piston over here that we left from before. We're now going to hook this all the way up to there so that it can switch off it can temporarily shut off the entire printer when it needs to. So for these purposes, it might actually be a good idea to make these spacing blocks melon blocks if you're in survival, because then the pistons, when they first extend, will end up breaking the melons. That's if you don't want to do any cleanup. So coming off from this sticky piston, come out 2 blocks, come up until there's 4 blocks like this, and then come out to the side like this until there's 7 blocks. And put a redstone block at the end. So there should be 7 blocks here. Next, come diagonally across and put a piston here, diagonally. If you want, you can put your melon block here. And then come out 4 blocks like this, come up 1, and then we're going to go to the side until there's 3 blocks like this, and put a redstone block right there. Next, we need to put 1 block of spacing like this, and put another sticky piston, and then we need to come out 5 blocks, and then return and come out another 4 blocks this way. So there should be 5 in total right here. And then put a redstone block at the end. And we need to put a sticky piston right here. If you space this out correctly, then this line of redstone blocks will extend up into this piston. And same with this sticky piston, being able to extend this piston. From there, come out 9 blocks and put a redstone block just like this. It's a little weird. Next, come another block out and place a sticky piston facing up. We now need to place 3. We're now going to go all the way up to there. So place 3 honey blocks here, place a redstone block on top of that, then 1 block of spacing, put another sticky piston facing up, and now come up 11 blocks. Like this, put a redstone block on top of that. Now we're just going to repeat until we get up to there. So again, spacing, sticky piston, 11 blocks, redstone block, and we space, sticky piston, and up 11. And a redstone block. If you space this out correctly, then the last this is the 3rd extension here, should line up exactly with this glazed terracotta. Now we're going to hook up the off switch, or the on-off switch. This is something that's also more or less customizable. So you actually need to replace this block with a glazed terracotta. And put that repeater back. It's facing this way. And then place a redstone block next to the glazed terracotta. Make a little L shape like this. And then come out 4 blocks. Just like this. And then place a sticky piston facing up into that. And then you can dress this up however you wish. Essentially, this is the actual. So if you want, you can put a redstone dust here. And then come up a block, place a redstone lamp at the end. And then power it. Make sure that this redstone block is up like this. This redstone line should be powered, and this line of honey blocks and slime blocks should also be extended, and this sticky piston should be extended into these honey blocks. The printer is, technically speaking, complete. All we now need to do is put in the instruction storage. So this is now going to be expandable. But from here, from this redstone repeater, we need to come over 3 blocks, place redstone here, and then come down a block and down another block, come out 3 more blocks like this, and then come over 2 blocks, make that 1 block, place a sticky piston facing up with the block on top of that, a block on the other side of the sticky piston, and a repeater set to 2 ticks. And then place a block, a redstone dust, and a redstone torch. Now grab your hoppers and make them come from this redstone torch, connect them to the dispenser. And then you can put a double chest on top of that. If all you have is a double chest worth of instructions, this is it. Your printer is now complete. Ooh, the timestamp is approaching. The timestamp when all the people who skipped the block by block tutorial are coming. What do I do? Here they are. And that is how you make quasitronic residue superconduits. We're now going to move on to building the instructions. These instruction modules are expandable, and as such, they're probably relevant if you are building this from the world download. You'll need to extend these from what you have in the world download. If you have more than a double chest worth of instructions, perhaps you have 3 double chests worth. What you're now going to want to do is place a block next to this hopper, place a comparator on that hopper, on the block actually, come up a block from the comparator, place a sticky piston, and then grab a redstone block and put it on the sticky piston. And actually what you're going to want to do is put a redstone block on top of the chest here. Then put a hopper facing down into this chest, and then put whatever other chest you want on top of that. The reason you want the redstone block here is because when you're loading in the shulker boxes, you don't necessarily have to do it from the bottom chest going up, or maybe you're using a structure block to bring in all the chests. And in that case, you don't want the extra shulker boxes from here to be leaking into the hoppers. If you want to add another chest on top of this, just place a block next to the hopper, place a comparator on top of that, come up a block, and place a sticky piston going this way, put a redstone block on top of the chest, again, 1 block spacing away from the sticky piston, and put a hopper on top of that, and go ahead and put your double chest on top of that. Now here's the thing. You can repeat this comparator and chest setup all the way up to the sky build limit. And this is why I recommended not to make the actual 3D printer too tall, because you might actually end up bumping into the sky build limit, in which case you will need to have another set of instruction chests, assuming you don't want to go back and forth to wherever you're storing your instructions. So to make this second set of instructions come after this set, what you're going to want to do is grab your hoppers and make something that looks like this. So just needs to go around this block with the comparator. Come down a block from the comparator and place a repeater set to 4 ticks. Come up a block from the repeater, place a redstone torch on top of that, and then put a block on top of the torch and a block on the side of the torch. And then come all the way over here. Now, over here, come out a block, place a piece of redstone, come out another block and place a repeater underneath this kind of bridge here. And now what you're going to want to do is come down a block of this bridge here. Go ahead and put redstone just like this. And then place a sticky piston and a block in front of the repeater on the face of the sticky piston. Now on the other side of the block, place another block and a redstone dust, and then put a torch on the side. This is going to be where you have your second tower of chests. So now, 1 block before that, get your hoppers and connect them up to the chest like this. And this way, you can just repeat that exact same comparator setup to add more chests on top like this. And there you go. Your printer is now 100% complete. You can now just take your instructions and put them into these chests in the order that you want the things to be printed. And, oh, one final step. Before you switch on the printer, you got to come all the way down here, take your random special item, which in this case has to be a nether star. It doesn't work unless it's a nether star. And then put it at the bottom dropper like this. And now your printer is now primed. Everything is ready to go. All you have to do is put in the instructions and flip the switch. Although, when you put in the instructions, what you're actually going to want to do is put a button here and press it 3 times. And this way, you get the first shulker box into this spot here. And you got to do this before you switch on the circuit. So let's say you were a sane person and you wanted to program the 3D printer manually. So the printer receives instructions in the form of dies and stained and glass panes or whatever item you choose in shulker boxes. So let's say you wanted to program this row right here. Specifically, the row is 5 blank spaces, followed by 5 concrete, followed by the rest being blank. This makes a 27 wide area right here. 27 is important because there are 27 slots inside of a shulker box. So, first of all, when you are programming this thing, you got to program from right to left because the actual printer will mirror your build by default. So if you program from right to left, your print will turn out exactly in the way that you built it, like this. So to program this set of 27 blocks, what you'll need to do is see that there's 5 blocks at the end here, which need to be blank. So fill up these 5 slots with in this case, the blank spots I'm using is gray stained glass panes, followed by 5 concrete, and specifically this is light blue concrete. So I'll be using light blue dye to signify that. And then the rest is blank. Just like this. Make sure every slot in the shulker box is filled, just like this. And then that is one set of 27 blocks programmed for the 3D printer. And if you have just a set of 27 blocks that's just completely blank, that is totally fine. Just go ahead and fill every single slot with the gray stained glass panes. Technically speaking, you could stack up these glass panes with each other, but I would not recommend doing that because you could very easily lose track of how many blank spots you have. So this set of 3 shulker boxes going from left to right will program, well, if I put this into the 3D printer, the 81 by 81 size 3D printer, it will program this shulker box first, followed by this one, which will make this entire 81 block wide row. And if you were doing this manually, you got to make sure that your first shulker box is first, so the slots in the chest go from left to right and top to bottom. So this first shulker box needs to go in the first slot. This next shulker box will need to go in the second slot. And this third shulker box will need to go in the third slot. In that order. Order is incredibly important if you want to avoid misprints. So these shulker boxes in this chest will program this row. It really is that time-consuming of a process. That is, unless you are in creative mode and you have access to data packs. So I have made 2 data packs that come with the worlds that I left in the description. I also have the data packs available separately in the description. So these data packs are data pack enable, 3D printer, as well as 3D printer 2. These 2 data packs are what you will need in order to kind of speed up the process and automate it just a little bit. And now I'm going to show you how to use these data packs to program your own instructions for the 3D printer. So now to use the data packs, the first one we're going to use is 3D printer 1, or just 3D printer. So the first thing we're going to do is type the command /function 3D printer : activate. Now what this is going to do is give you 2 armor stands and also activate a few scoreboards. So I'm now going to show you what these armor stands do. So first slot armor stand is what you put at the beginning of your row at the rightmost edge / corner. So this data pack by default will assume that the rows go in the negative x direction and that the next row will go in the negative z direction. Now, the target armor stand is what you put on top. So first of all, I'd recommend laying out just a bunch of shulker boxes like this in just a bunch of strips. The number of shulker boxes you need per row is the number of blocks in your row divided by 27, rounded up. So put your target armor stand on top of your shulker boxes like this. This target armor stand will, this data pack also assumes that for each row, your extra shulker boxes in every row are going to go in this direction here, the positive z direction. And the next row's shulker boxes will be going in the positive x direction. That's kind of the default settings. You'll need to actually change some of the code of the data pack in order to change those directions. But it's perfectly designed for the world downloads. So now, all you have to do is, I recommend going back over to where you placed your first slot armor stand. And now you need to tell your data pack how large your print actually is. And this can be done with scoreboards, players, set at p, and here you need printer1 underscore blocks. So that's your indication, and set this to however many blocks there are in your row. In this case, that is 81. Now you are ready to program. All you have to do to program one row is to activate the function 3dprinter:_AAA row. I intentionally added 3 A's here just to make it nice and easy, so you can it'll always appear at the top of your list. And there you go. It executes a bunch of commands, and that was probably a little too fast to see. So I'm now going to show that again. There you go. Now note that I placed this first slot armor stand so that right above the head of the armor stand is your actual print right here. That's because of the way that data pack was designed. Essentially, this armor stand will look at the block directly above it. In this case, that'll be this block, and it'll be testing to see if it is air or some color of concrete. And then whatever block it detects, it's going to send over to the target armor stand, which is then it's basically going to tell this target armor stand, hey, I found some air, so put in some gray stained glass panes. And that's what it's going to do. So you just activate this a few more times. You can activate this as quickly as your computer can handle. You could even hook up a redstone signal. You could even hook up a redstone clock if you want. But it really does program with all the dyes in mind. The assumption is that air is going to be gray stained glass panes, and the concrete is going to be dyes, which is exactly what is found in the world downloads. This does not have to be the case, but in order to change that, you will need to go directly into the code of the data pack and change it for yourself to whatever items you specify. And I meant it when I said you can hook up a redstone clock. You really can just hook up a redstone clock going directly into the command block that sends out the function 3dprinter:_AAA row. So once you once you have satisfactorily filled out your row, or filled out your layer with all of your rows, I'm just going to fast forward to that. Oh, and if your target armor stand runs off the shulker boxes, no harm is done whatsoever. All that happens is, well, nothing. This target armor stand just really doesn't do anything. And same with this first slot armor stand. Now, if the first slot armor stand sees something above it that's not either air or some color of concrete, it's not going to put an item into the shulker box. So beware of that. So now I'd say that is satisfactory. So now we can put all these shulker boxes into some chests, which we can then load into the 3D printer. Now note that if you're going to use structure blocks to move your instructions to the world where you have a 3D printer, assuming your build is not in the same world as your 3D printer, you're going to need to space out your chests every other block like this. So from here, you can either break these boxes manually. So in this case, beware that this is your first shulker box, then this one, and then this one. And make sure that you shift click into the chest in that exact order. Or if doing this to 243 shulker boxes is a bit of a hassle, which let's just admit that it is, there's so much room to make a mistake. But not when you have the Datapack 3D Printer 2. So once you download the 3D Printer 2 Datapack, you can then set off the function 3D Printer 2 :activate. This will give you 2 more armor stands. This, you have shulker box destroyer and shulker box receiver. Somewhat self-explanatory. Shulker box destroyer you place in the same way that you placed your target armor stand, specifically directly on top of the shulker boxes, and it's going to assume that each row of shulker boxes goes in the positive Z direction, and the next row of shulker boxes is in the positive X direction. As for shulker box receiver, I'd recommend grabbing a hopper and putting it into the chest where you're going to put your instructions. Now, shulker box receiver is going to assume that you're putting your instructions into double chests. So if you put them into barrels, you're going to need to manually modify some things directly in the code. But now that you've activated the data pack, you now need to set a scoreboard. In this case, the scoreboard we need to set is printer2_shulker. Set this to the number of shulker boxes you have per row. In this case, that number is 3. We have 3 shulker boxes per row. And then place your shulker box receiver on top of the hopper, and that directly filters into your double chest. And now when you start your row, what you're going to want to do is set off the function start breaking, like that. That just resets anything in case you did anything with the data pack before this particular row. You're going to want to activate that just to reset things. And then notice how I have the scoreboard Z don't touch this. I put the Z at the beginning just so it's at the bottom of your list. And really, seriously, don't touch this. You can't touch this. Boom, 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 boom. Can't touch this. And once you are ready, type the function 3D printer 2 :AAA destroy boxes. So what that's going to do is it's going to precisely calculate, it's going to essentially move this armor stand to destroy exactly 54 shulker boxes and teleport every single one of them to the shulker box receiver. Now, hoppers are pretty cool in the fact that the shulker boxes will appear in this chest in the order that they need to be in order to count as valid instructions. And even if the number of shulker boxes you have here is not divisible by is not some multiple or divisible factor thing by 27 or 54, this shulker box destroyer will end up just hanging out in the middle of the row, and that's totally fine. Just yeah, it'll just always calculate exactly 54 shulker boxes. Once you have the 54 shulker boxes, you can then break the armor stand receiver armor stand and move it up to the next chest, place it back into the hopper, and then activate it again. Don't accidentally pick up the shulker boxes. And then whenever you're ready, you can even break the armor stand while the shulker boxes are still figuring themselves out coming into the hopper. Place another hopper, put the armor stand receiver in, and break the boxes. Now the thing is, this shulker box destroyer really does destroy the blocks, so you could end up in trouble if the shulker box destroyer goes over non-shulker boxes. It will just gather the drops and teleport them over to the hopper, which will put them into the chest. So be careful with this one. As you'll see here, it really will just destroy the blocks underneath the armor stand. So yeah, but then you can just break the shulker box destroyer, and you can also break the shulker box receiver, and you'll see that the polished diorite that the destroyer broke will just filter into here. This is another reason why shulker boxes are used. It's because notice how there were more items in the hopper? They were just kind of stacked up. That's not the case with shulker boxes, that's part of the reason they're used in the instructions. So there you go. These 5 double chests right here, including this incomplete double chest, constitute your entire first layer of this island print. Now, of course, when you finish a layer and you want to move the shulker box destroyer back to now destroy a different line of shulker boxes, you will need to activate the function start breaking again. Don't forget to do that. If you do, your destroyer armor stand might act weird. So just to demonstrate that this really is expandable, I'm now going to place the armor stand receiver on top of this hopper here, and I'm going to place the armor stand destroyer at the beginning of this platform of diamond blocks. So again, remember, set your scoreboard players set at P printed2_shulker. In this case, we have 10 blocks in the row right here. In this case, these are diamond blocks, but the data pack doesn't care. And since we are starting a new new quote-unquote layer, we need to activate the start breaking function, and then function AAA destroy boxes. And you will see that it really does break all the blocks. And this armor stand, even though 10 is not divisible by 54, it shares really no factors with 54 or anything like that. As you can see, the shulker box destroyer armor stand just kind of hangs out in the middle of the row. But that's totally fine. You can just keep activating this over and over and over. Absolutely nothing goes wrong. There you go. The only case where this can even theoretically go wrong is if for some reason you have 54 shulker boxes per row, in which case, good grief, actually this data pack is not designed to handle that. So you won't be able to even if you wanted to. Sorry. If you have a 3D print that involves 54 shulker boxes per row, please send it to me. I'm on Twitter at JavamonkYT. Please send what build you're doing, because I'm pretty sure even full-sized maps aren't that big. So if you want to see the kind of redstone signals the redstone systems you can set up to make the make the data packs even more efficient / AFKable even, then this world will also be available in the description, and you can just change out this dragon to whatever you want. In fact, you can use like structure blocks to just import your build into here if you really wanted to. I'll make sure you change your data packs and change your scoreboards as fit. So the dragon statue, some fun facts about this. Every layer takes 2 structure blocks worth of towers of double chests, which is pretty insane. So over here, I actually have command blocks, all designed to they're all kind of designed to do the placing and breaking of the armor stands kind of automatically. So I'm now going to show you how this works in action. I have some command blocks that place an armor stand and then begin the process of programming the row. So we're just going to do that right here. And you can see we're off. So these armor stands generate and move automatically. And although it looks like there's a whole bunch of armor stands being spawned all at once, it's actually only 27 armor stands. They're just being killed and summoned very quickly. But you can see over here, I have a sort of just little redstone clock that just activates this command block, or this command block tower just over and over. A few of them are counters, so that way it can detect when when the row ends, because that's not a feature of this data pack. So you can see there. And now a different command block setup jumps into action, and that's the shulker box destroyer mechanism, which will both destroy the shulker boxes and also teleport the shulker box receiver up this hopper chain here in kind of a zigzag pattern, so that way the armor stands don't have to move all that much. Or at least the setup doesn't have to move. Yeah, it looks like the fact that redstone clock wasn't in render distance at first made it so this set of instructions is more or less incomplete. But now you can see I have a command block to detect when there are items, and then this tower of command blocks activates once everything is ready, once all of the items are in the chest, at which point you can then go over to your structure blocks and name your instructions whatever numbers and save them. And that's it. And then teleport back, place a block on top, and that is where the next armor stand will land to then program the next layer. Yep, I just did that over and over 62 times to make this dragon statue. No, I'm not going to do a block-by-block tutorial on this command block setup. If you really want to know, you can just download this world. It's really not part of the tutorial, and also this was designed for me and for this dragon statue. I did not build it with customization in mind. One last note before I finish off this video and finish off the showcase / tutorial is that once you have all of your instructions in place, you will actually need to have one more shulker box filled with only 2 of really any color. I chose the blank, which in this case is a gray stained glass pane. And you need 2 of those as your very last shulker box instruction. And this is simply because there are 2 extra blocks down there next to that piston. And if you don't do that, your last row of the print will actually be incomplete. Oh, and if you are coming off of the world download, like you did not build it yourself, before you activate the 3D printer, you'll need to push this button. And that's simply to get the first 3 shulker boxes out of this chest, which will then prime the 3D printer. Like that. So now we will 3D print the Mario that was used in Ilmango's original 3D printer design. And this is actually one of the very few worlds that doesn't have die as the sorter, because I literally just took the exact same instructions that Ilmango used to make the Mario pixelate. And now we will give this Mario the justice that it deserves by 3D printing it. And that is going to do it for me today. I hope you enjoyed this. If you did, please let me know. And we got about 5 minutes left in this in this very amateur replay mod footage. So here are some fun facts about this 3D printer. So I'd like to tell you about how long these things will take to print. So, starting from the smallest size, you have the Wither statue, a 27 by 13 platform, something so small that you don't even need the system that briefly stops the machine when the flying machines are flying. So, one layer takes about 5.5 minutes to print, assuming ideal conditions and you're not using carpet mod. These are just assuming ideal. So it takes about 5 to 6 minutes per layer, and the full model, which is 27 wide by 13 rows and 22 layers, takes about 2 hours to print. Now, the Mario statue, which is has 27 blocks per row, 27 rows, and 9 layers. Each layer takes about 14 minutes, and the full model also takes about 2 hours. Now, the 54 by 54 sized print, one layer takes about 56 minutes, or about an hour, and you have the option. One of the world downloads has instructions for a gigantic smiley face that you can print. Now, that also has 8 layers, and so the full model will take about 7.5 hours to print. The 81 by 81 size has each layer takes about 2 hours to print, and you have the option to print the island that I made in episode 42 of my survival series. That model has 41 layers, and that entire model takes about 3.5 days to print. Straight, assuming you don't turn off your computer or anything. 3.5 days straight. And then, of course, the go big or go home. One layer is 270 by 249 blocks. Each layer takes about 21 hours to print. And the full model, which is 62 layers, will take approximately 54.5 days to print. Yeah, that is not messing around. Thank goodness I have carpet mod, because all of those times are going to be knocked down by pretty significant amounts, simply through the use of /tick rate. In any case, I hope you enjoyed this video. If you did, please let me know, and I'll see you next time.